Well, it looks like we can start. Welcome back, everyone. We're just about to finish off week number 1, so 15 weeks to go after today. Before we get started with the announcements and the course material, any questions or comments whatsoever to start us out today? Okay, well, let's begin. Last couple of class periods, we've been pushing forward just a little bit in the coursework, spending a good amount of time introducing the class in one way or another. Just for the sake of if you're joining the class, say recently, maybe on Wednesday, the online textbook can be accessed here. Everyone needs to hit that link at least once to pair the Canvas course page with the Pearson's MyLab homework system, where you can get the textbook. And then you can always follow these links here. They're going to be under the lecture notes for the actual homework on each section. We're, most of the way through chapter 1. We might be able to finish it today. And if we need to take extra time on finishing it, I'll be pushing the due date back further so that it's always 1 week away from when we fully complete the section. But currently we're on example 3, about to dive back in. We're really focusing quite hard on this chapter 1, on looking at context of different situations, statistical studies, breaking down the context into all the moving parts. And now we're going to focus a little bit more on data and variables. But any questions or comments so far? Okay, well, let's jump in. Here's where we left off last time. Our definitions are very short. It says a variable is any characteristic whose value may change from one individual or another. So, like many definitions in a math class, particularly a statistics class, isn't any different. Those definitions, you could memorize them perfectly, have it down in your head by rote memorization, be able to say exactly what that definition is, but actually working with that definition practice is a whole new thing. So when we mean variable, one example was really just the last example. In this big study here, where they were having people blindfolded and going from one end of a football field to the other end to see if they'd go out of bounds, the variables was the what that was measured in the study. They measured sex, height, handedness, number of yards until off course, or number of yards, and then whether they were off course, left or right. Those are the things that changed from one individual to the next. So we call those variables. They vary from person to person. So that's all we mean by any characteristic that may change from one individual to another. It could be actual people when we say individuals, it could be animals, things, anything whatsoever. Then the next definition is that data results from making observations either on one variable or simultaneously on 2 or more variables, like in the last study. So down below, we have some data, but any questions first about the working definitions? Okay, well, this time the context is really very, very short. This is actual real data. I just didn't have the citation of where it came from. It says, just to give us a feel for what's going on in this problem, mercury is a metal highly toxic to the nervous system. I think we have an open mic. Oh, I think it's fixed. And they did measure average mercury in parts per million and many other things in this data set. It goes on to give us more information. Below is a small part of a data set from a study that assessed water quality of 53 representative lakes in Florida. When it says 53 representative lakes, what they're meaning is N, which is the sample size, takes on the value, N is 53 here. There are many, many more lakes in Florida, but they selected the 53 lakes in a way that any typical lake in Florida is going to be about like one of these in the set. So they're not all, say, gigantic lakes. They're not all very small lakes. They're not all freshwater lakes and so on. So that's our whole data set. And again, they measured many different things. There's a header for pH, chlorophyll, average mercury, number of fish sampled, age of data. If you're a little bit concerned about the table, there's 1, 2, 3, 4, 5 rows, and then dot, dot, dot. And that's what they mean by it's just a small part of the data set. Sometimes just so that the space on paper doesn't get too wide and we have to scroll a whole lot, we're just showing a section of the data set. And the dot, dot, dots here just say, and so on. Next row, row 6 for a different lake, row 7 for a different lake, until you get to the bottom, row 53. But we're just looking at, say, the very top of the data set. So that's our context. And we briefly talked about this before we ended class last time. We were kind of short on time to really put this down on paper. But when it says to describe the sample using the context or the population using the context, great way to think about that is just go through the definitions again. For preparation of, say, taking an exam, writing down your page of notes, it won't be bad to write down some of these definitions, especially if something's been highlighted already in the notes. That's a good kind of giveaway. It's a big, important definition. So see the definition again for population sample. Sample is the part of the population selected for a study. And here they selected 53 representative lakes. Looks like they're talking about the sample there. It says next, the population is the collection of all individuals or objects, this time objects for lakes, you want to learn about. So that tells us when we talk about the 53 lakes, that's really the entire sample. Does that make sense to folks with identifying the sample on this one? Okay, so I wrote this in red after the fact of publishing the notes, because this is once again how we would really write down a question on quiz setting or exam setting. When we looked at it in class, I realized that part of the instructions is pretty critical, so we included it. For the sample, using the context, we might just say something really briefly. The 53 lakes in Florida selected. So that's our entire sample. And because a sample comes from the population, when we go to describe the population, really we're saying almost the same thing, except we include that word right there. We're just talking about everything, all of the lakes all at once. That's what forms the population. So for the population, we can say all lakes in Florida. Let me spell Florida correctly. There we go. So that's the population and the sample altogether. Any questions at all, folks? Running through parts A and B? Okay, well, this time it was a little bit faster to find the population and sample. If the context is really short, it does help. But again, these are all pretty tricky definitions, so we'll be going through these quite a lot, not just in this chapter, but many of the rest of the chapters as we're going throughout the course. Now, looking at this data set, it's describing 53 lakes. We have pH, chlorophyll, measured in milligrams of the lake water, or probably differently, milligrams of the chlorophyll per liter of the lake water is more likely what that unit represents. Average mercury in fish in parts per million. That's kind of a sketchy looking thing there, because you might wonder, how did they measure that? They can't take every fish. But that's what the next column is saying. When they went to a lake to determine the average mercury in fish, they grabbed some fish out of the lake. They sampled, and this column is just telling us how many fish they grabbed. For first lake, just 5, some of the lakes 12. We don't know for the rest of the data set how many they might have sampled. And because sometimes with statistics, the age of the data is important. Things change in ecosystems. Florida lakes aren't static. Things like mercury change over time depending on what's going on in the ecosystem, local, nearby industry. Also, the age of the data is also recorded. It's either year old, recent, year old comes up again. And maybe if we saw the whole data set, something might say 2 years old or so on. But this is how they described age of data. Well, this altogether makes up the data. It's observations made on multiple variables at the same time. And looking at this, how many variables would you all say must be here given this data set?
5.
Yeah, absolutely. Every one of these columns is describing a variable. So altogether, we would have 5 variables. Let's write here, 5 would do the job. If you want to be a little bit more descriptive, doesn't hurt to say 5 variables. But if you just wrote down the number 5, that would completely answer that kind of question. You don't have to do much more than give a number. If it says using the context is lakes in Florida is the major thing you would have to say for both population and the sample. Let me underline them this way to convey that's what we meant by the context. So that was our first look at variables. And if you look closely at these variables, they're not all the same. Some of them are numerical values. Others are just verbal descriptions. Year old, we might think of as a numerical 1, but recent, that doesn't have any sensible numerical value. In some sense, age of the data, this particular variable, it just seems like they're categorizing the lakes in one set or another, whether the measure was made recently or a while ago, a year old. So there's different kinds of variables, and depending on the type of variable, that will inform us how to form graphics of the data, visual displays, what kind of statistical tests we can run on the data. And so that's what the next part of the notes is going to get into. What kind of variables will we be looking at in this course? And chapter 2 will tell us how to provide graphics depending on the type of the variable. So we're on to example 4 now, but any last final questions or thoughts on this one? Okay, I think that's the fastest example we've solved. So not every problem we solve is going to take quite a lot of time. I think example 2 took easily about 20 minutes to get through. So here's our next one. We have lots of dichotomies in statistics. One dichotomy is population versus sample. Another dichotomy we'll get back into is parameter versus statistic, like we looked at under example 1. And yet another dichotomy is a categorical variable versus a quantitative variable. You could call categorical qualitative if you like. You could call quantitative a numerical variable if you like. But I'll usually go with the first names whenever I discuss these variables in my own lecture notes and in class. So let's go through these together. We'll give some examples of both types of variables and then look at a brand new data set down below. So first one, categorical variable or qualitative. Well, let me read it in order. A variable is considered to be categorical if the individual observations are categorical responses. That almost seems like we went in a circle, right? But what we mean by that, categorical responses, is we're just trying to classify the individuals of study to belong to one set or one group or another group and so on. And one fast example, we'll provide some more. Zip codes are categorical. All a zip code does in USA is say, what region of the country are you from? So write down a zip code, and that's a categorization. It's kind of weird because if you write down a zip code like 834012 or something like that, was that a zip code? 83407, something like that. So I should get the digits right. Then it is a number, but just because you're looking at a number, it does not imply immediately that it's a categorical variable. For example, imagine you have 20 zip codes altogether. Some of them might be the same. It could be 20 completely different zip codes. If you took the average of all those zip codes, that might not make any sense whatsoever, what you're trying to do. The average of a set of zip codes is probably not a real zip code in the very first place. So if it never makes sense to take an average, that's one way you can determine you're looking at a categorical variable, even if it shows up as a number. So zip codes, student ID numbers, anything along those lines would be considered categorical variables. Well, that's the variable. We'll put down another example down below just to have a better idea for what we mean by categorical variables. But any questions about them so far? Okay, well, here's my next really fast example. Let's name a population. We need a population because if you say individual observations, we mean observations on either people or things. And so we are already thinking about a population as well. So to give an example, we begin with population. And let's let the population here be all Idahoans. So everyone with a Idaho residency might be one way to define something like this. For a categorical variable, let's say variables for a plural. This could be something along the lines of, let's say, county of residency. Maybe another categorical variable could be, this is just kind of a random variable, blood type. I have no idea what this study would be about, but let's put it down. These are considered categorical variables. I forgot to spell that right. There's an L right there. These are categorical variables because if we have a sample of Idahoans, the county where they reside in, that's just putting them into different groups where they came from. Blood type is also categorizing everyone inside the sample. And any volunteers for maybe another categorical variable that might have popped into your head?
Age.
Not quite age, because with age is something that we could consider to be numeric. But to be completely fair, that really just depends. It depends on how are we recording their age. If we're recording their age as, say, 57-year-old is the first person, 12 years old is the second person, 33-year-olds is the third person, and so on, we're probably thinking of numeric. But if you record age as something along the lines of maybe minor, adult, senior citizen, if you're putting them in categories like that, it's absolutely categorical. So let me put that down with the clarification. Let me see if I can get type to stay put. There we go. I'll put that down with the clarification on age. And absolutely, Haley, phone numbers would do the job as well. That would absolutely be area codes for phone numbers would be a great way for a categorical variable. So I'll put here area codes for short. And let's put here with a qualification, age, if recorded as, any grouping that might make sense. It could be one category as minor, another category adult, another category senior citizen, and anything along those kind of lines that just places people into categories. If the categories are 0 to 21, 22 to 35, 36 to 47, those would be ranges of values, not just one single number like age 19, age 52, along those lines. So if you are just grouping people according to categories in any kind of way, it becomes a categorical variable. Well, categorical variables, they can be kind of tricky to think about sometimes. So we're going to practice this in a lot of different exercises. But any questions at all, folks, with what we mean by categorical? Okay, now these definitions I typed out of our textbook pretty much verbatim, so we have to be kind of careful with these. Sometimes it feels like the definitions might contradict each other, but there's extra clarifications that go along with this. This is where the reading becomes really important to see what those clarifications are. So when it says a univariate data set, it just means a data set that contains one variable. We're just considering one variable at a time. We'll say one variable is quantitative or numeric if each observation is a number. But you might say, hang on, zip codes are numbers. We said that's categorical because it's categorizing people geographically. But what the reading would clarify here, add more to the text on this, is if each observation is a number, where it does make sense to take an average. So for example, if we had a data set that had ages of individuals, you could ask about, well, what's the average age? What's the mean age, said differently, or the median age? If taking an average makes sense, your variable absolutely is quantitative. So this is one way to spot a quantitative variable. But another easy way to spot it is quantitative variables have units. Units might be age. They might be a distance in miles, kilometers. They might be a number of time in, say, seconds, hours, nanoseconds. They could be the concentration of chlorophyll in a liter of lake water, like in our prior example. Anything that has a unit altogether attached to the number makes it a quantitative variable. Zip codes, they don't have units. They're just a number to describe a region, a categorical region of the United States. Same with area codes. Doesn't make sense to average an area code nor a zip code. And so this isn't the whole story of what makes it a quantitative variable. It's not just that it's a number, but the number is something you can average. It has a unit attached. So that's what a quantitative variable is altogether. And the fast example I included in the notes said, variables such as ages, I guess I kind of said that verbally, are numeric since it does make sense to find the average age. Well, we'll put down another example once again, just to get a bigger feel for quantitative. And for our next example, let's let the population be the following. We should grab a whole new population. Let's let this population be all ISU students. Now, if I leave the population off right there, this is a gigantic population. It's not really clear what I mean. Do we mean all current students registered for this term? Do we mean all past and current students? Do we mean future students that are ready to go? They're registering for spring already. That's, again, a very open question of what we even mean by the population. So we often, when we write down a population, try to be specific. Let's say for this population, it's all ISU students registered for the fall 2026 semester. Still, it's a big population. We have ISU students who are on the main Pocatello campus. Some of them are students considered to be attached to a satellite campus, like the Idaho Falls campus, the Twin Falls campus. There's a campus on Meridian near Boise. Or some of these students could be online. They could potentially be out of state even. So we have still a pretty big population when we say all ISU students registered for the fall 2026 semester. You are a part of that population, so congratulations, welcome into this example right here. We want a quantitative variable, so let's write down some examples. A quantitative variables. This could be something maybe along the lines of, how about, let's see, there's lots we could write. Number of credits, let's say this differently, number of registered credits. Some students might have, say, 12 credits, meaning the full-time requirement. Some people might be taking only one class. Potentially that's someone in this class as well. In that case, you are taking 4 credits. Some people might have petitioned the university to take up to 22 credits. Some people just have an extreme amount of energy and they can make that happen, and they petition to be allowed to do so. It does have a unit. The unit is credits. All of these are just numbers. They're integers. You can't have a 3.5 there. To my knowledge, there's no half credit, but they're numbers. The unit is credit. And it does make sense to say, what is the average number of registered credits for a sample of ISU students, or even all of ISU students? So that would make it a quantitative variable. Any questions about that one so far? Or if you're thinking about another quantitative variable, any volunteers for what might be considered a new quantitative variable for this?
Could it be like a GPA?
Yeah, absolutely. Good call. Thanks for that one, Nakizaka. Another great quantitative variable could be GPA. This one, the unit is itself. If you put down, say, 3.7, 4.0, the unit is GPA. We can ask and answer what is the average GPA amongst individuals in the population or the sample. And you can imagine many, many more things. You could put all sorts of weird stuff in there. Again, it's hard to know what the study is going to be about if you said height, but that's a variable. You could conceivably measure the height of all ISU students, or take a sample of maybe 100 ISU students, measure their height. Maybe you could be measuring the distance that they have to commute to their nearest campus or nearest class. That might be a tricky one, because maybe if it's an online class, the distance is 0. Maybe some people live on campus, but some people have to commute pretty far just to get to class. 50 miles, 20 miles, those are not unusual numbers. Anything along those lines that has a unit like miles, GPA, credits, or centimeters, maybe if you're measuring heights and those kinds of things, those would all be considered quantitative variables. If you want a categorical variable for the same population, all ISU students, categorical variables like major, college, or maybe class level, freshman, junior, senior, graduate, and so on, those would be all categorical, because we can't take averages of those kinds of categories, but we can for these kinds here, the quantitative examples. So that's our 2 definitions. And anything that just says example, like we did here, this is just meant to be a space in the notes where we can think about the definitions a little bit more just before launching into a problem. Not a bona fide example, a real example that could be a quiz question or an exam question is always going to have a number. So example 4, those would be the bigger, fuller examples after getting through the definitions. So we'll take a look into that one next. And last final thoughts or questions on the 2 working definitions above? Okay, well, let's take a look into our example 4. This study is, I should admit to you every time I do one of these, this one's completely fictitious. It's just for the sake of understanding these 2 kinds of variables. Although it's fictitious, it's something you can imagine occurs as a study out there in the real world for big, large corporations. First thing we'll do is read through the context, see what's going on. It says a study was conducted to analyze the impact of different factors on the amount of time it takes for employees at a certain company to complete a project. You can already feel the corporate speak in this problem as we're going through it. So factors for the amount of time it takes an employee to complete a project. We're imagining that this is possibly a pretty large company, maybe hundreds of employees, potentially even in the thousands of employees. Imagine a big company like, say, Google, Microsoft, Meta, something along those lines. We're told a simple random sample of size 10. We'll come back to that definition, but what we mean by simple random sample is everyone had an equally likely chance to be in this sample. So there's no biases whatsoever. They just essentially took a listing of all employees, a random number generator, and grabs 10 people purely at random. So we have a sample of size 10 employees. Let's write that down just for the sake of indicating this variable, n equals 10. It's our sample size this time in this problem. It's selected from this company, and the number of days it took each employee to complete a project, along with the values of several potential influencing factors, are given below. So the study seems to be mostly about amount of time it takes for the employee to complete a project, but maybe it's not even fair to say mostly about. They want to know what influences the days to complete that project, that amount of time. And so it's also about all of these other values right here. So every row is a person. Their names have been omitted to protect their employee privacy. But if we look at, say, this line right here, this is a person with a master's degree, has been working for this company for 16 years, or that could just mean experience in the field, 16 years. That doesn't give us enough context to tell exactly what that experience column meant. Let's go with just for the basic one. They've been with the company 16 years. Here, maybe their supervisors have been doing yearly reviews of the employee, and they have a category in their personnel file of how well they communicate. This person has terrible communication. That sounds really bad, but again, out there in corporations, in personnel files, stuff like this probably be worded differently, but that's not an unreasonable response for this column. This person has a high workload, and it took this person 78 days to complete the project. So this is the context altogether. Here we have all of the data. So the data is everything we have here. And this row going across that's shaded in bold, these are the variables. Well, our job on this one is determine which variables are categorical and which variables are quantitative. And you can kind of organize these in a pretty fast way. You could just say categorical for one column, list them below, quantitative for another column, and then just list them below. So you don't necessarily have to say categorical, quantitative 5 times altogether when you write out the answer to this, although it wouldn't hurt if you did do it that way. Okay, well, let's think about this one for a moment. I'll give everyone, let's go for about 30 seconds of thinking time, and then we'll solve this all together. So I'll get quiet for the moment. Okay, that was about 30 seconds to look at what's going on with this kind of a crazy study here. Any volunteers for what variables must be categorical on this one? Haley says, would categorical be education, communication, and workload? Yeah, absolutely. Thanks for submitting that response there. I agree. Education, here we're taking it 10 employees and putting them into various groups. Some of them in the PhD group, smaller group there, some in the bachelor's group, some in the master. So that means education would go here. Skip over to the next one. You said communication. And yeah, absolutely. These are just descriptions. Some of them seem kind of insulting. Again, I think a real personnel file would probably word that differently, but the impact would be the same. And you can't average these at all. They're just ways that the people were grouped in this sample. So communication goes here. And same idea, workload. We have high, low, medium. These are not numerical values we can average. So we would say workload as well. So those would be the categorical variables of the study. And I mentioned before, this is considered to be a dichotomy. Dichotomies like this are really kind of nice because if you have a dichotomy, it means there's just two parts and both parts make up the whole. There's no variable that can fit in both categories. So if you're extremely confident you've got the categorical variable down, you've also got the quantitative variable. Just list out the remaining categories. It would be experience. And yeah, we have numerical values. There's a unit in years, and it does make sense to ask the question, what is the average amount of experience in years for the 10 employees in the sample? So that does fit the quantitative variable definition. Skipping here, these are integer values as well, days to complete. So those are ordinary numbers. The unit would be days. And so, yeah, absolutely. For the same reason, you could call this just days for short, but let me be descriptive in the notes. Days to complete would be the other quantitative variable. So that's our breakdown on this one, our second data table we've been looking at. Any last thoughts or questions about this one? Okay, forgot to put a blue check there just to finish off the way we were notating this. If you look at this really carefully, you might have noticed that some of the data is really kind of strange. We're just looking at a table like this, and it's not easy for us to process information with 10 rows or 53 rows, like in a prior example, with just values. But if you were really looking at this carefully, some of the numbers here might have thrown you off a little bit. Like, for example, the 78 here, 78, almost 80 days is wildly larger than everything else in the data set. That one's getting close to about 25, and this is getting close to 80. So this number really stands out. And maybe for the same reasons, maybe not as bad, but this one kind of stands out too. The next highest value is 7, double that's 14, and this is more than twice the amount of the next highest value, 7 years. So what we might say later on, excuse me, not might, what we will say later on, but we might as well start thinking about these things now, is when you see these kinds of things that seem to not really fit with the rest of the values, we often call these or consider them to be outliers. Let me make that singular on the note. That's an outlier as well. It really just doesn't seem to fit the pattern of the rest of the data. This one being a gigantic value, this one being quite a large value as well. It's not easy to spot on this table, so if you saw those and you felt like these were weird, good on you. If we could put graphics to this data, it might be much more easily, they might be much more easily spotted. So that's kind of what the purpose of chapter 2 is in our descriptive statistics. But we're nearly done with this chapter 1. I have one more question just to kind of finalize our roundup of categorical quantitative before we go on to the next chapter. Any last final thoughts or questions on getting through this one? Okay, well, let's turn the page. Here is the last one for the set of notes. It's pretty much the same kind of problem, but whenever you have a working definition like, say, categorical versus quantitative, population versus sample, a lot of times the way you can ask the question can be pretty creative. The last problem just threw data table at us. This time we're just looking at 5 different scenarios altogether, A through E. Each one of them implies a population, some kind of studies being done, but we're just looking at an extremely narrow band of context, and based off what was being measured, determine if the variable is going to be categorical or quantitative. So same idea as before, but a really briefer kind of problem in a certain sense. So just classify each of the variables. If it said explain here, we would have to say more, but I try to write my questions very similar to how they'd be written in a real setting of, say, an exam or a quiz. If it doesn't have anything here for explain, it means all you really have to say is categorical, quantitative, and then your work is immediately done. So let's go through these. First one just says weight in ounces of a bag of potato chips. Any volunteers for what that feels like? Should that be categorical or quantitative?
Is it quantitative?
Yeah, absolutely. So this one's quantitative. And now our job is done on that one. But even though the response is 100% complete, we're doing this for the sake of notes, right? So anything that I put down as notes that goes beyond the problem, I usually use this color of pen. So that's my just way of saying you didn't have to say more, but we are saying more just to clarify why we answered it that way. So why would you say quantitative on this one? What's one tell that gave you our response?
I feel like the ounces.
Yeah, good call. Absolutely. That's what jumps at me as well. Once they say something that's a unit like ounces, absolutely it's quantitative. So we'll say here quantitative, a unit is given. Some people might say for their justification here, just for the sake of notes, it does make sense if you have a whole bunch of bags of potato chips to take the average weight, see how much that varies from what the bag says. If it's a 16-ounce bag, you could take the average and see how close you are to that. So if you can take an average, or if there's a provide unit, it must be quantitative. Well, that's one down, 4 more to go. I think these ones are kind of fun because it's really just getting right to the heart of the 2 definitions here. And same idea. Now, if it says number, that's not enough to determine quantitative versus categorical. But if it goes on to say number of items, items is the unit. Number of items purchased by a grocery store customer, it makes sense to average how many items the store's customers get. So for the same reasons, we can say quantitative on this one. Let's give a different description. This time we might say it makes sense to take an average. Or you might word that, let me spell that correctly first, average, there we go. Or you might word that by saying it makes sense to find the average number of items purchased. So we have quantitative on both so far. Any questions on either one at the moment? Or any volunteers for what part C should be?
Categorical.
Yeah, absolutely. Good call, folks. In chat as well. We have categorical, Haley says, because it's specifying the brand. Therefore, we're categorizing different brands of cola that could be bought. Absolutely. We're not looking into, say, the sugar content, which would be quantitative, or the ounces, nothing along those lines, just brand. So here, categorical. And I'll abbreviate by saying we're classifying the cola based on, we could say, brand or the maker of the cola. I'll go with just brand for short. So categorical on that one. And same kind of idea in part A. Sometimes a big giveaway is if they state a unit, you're almost certainly looking at quantitative. It says amount of gas in gallons purchased at a gas station by a gas station customer. This is enough for us to say quantitative. Let's say here, unit given for the sake of the notes. And for part D, part E seems like it's possibly the same study. Part E is asking about the type of gas, regular, premium, diesel, purchased by a gas station customer. Well, this one's a big giveaway as well. Didn't happen in part C. I think part C is trickier because it just says brand of cola, but it never told us what brands, right? We have to imagine on our own what brands might qualify. But here, if it says type of gas, you could rephrase that as categories of gas. If it lists out categories, it's got to be categorical. So part E is categorical as well. And for the notes, I'll just say categories are given. Here they are, 3 categories. So that's really big giveaway for that one. Making maybe part C, if this was, say, a real exam question, part C might be the trickier one. But if you think of, is there any units here? Are we taking an average? Would the average make sense in any kind of way? That would direct us to definitely categorical in part C. So we did it, folks. Those are the 2 different types of variables that we're going to be studying, quantitative versus categorical. Sometimes it's just one quantitative variable. Sometimes it's just one categorical variable. And sometimes we'll be taking a mixture of both of them all at once when we're looking into our study. Any last final thoughts or questions on getting through this last example here? Okay, well, now that we've gotten through the notes, I just want to spin back to this very first example. That's not it. It's this one up here. This one had a variable too. And we'll put down the response on this. Let's use this color since it'll stick out a little bit more. This color is called plum if you're curious. We were looking into the technology underlying hip replacements. We were told it's changed a lot over the years. It's become popular. Starting in 2003, highly durable ceramic hips, were marketed. We're told that some of them began to squeak. And in this study, we have 143 individuals who received ceramic hips between 2003, 2005. 10 of the hips developed squeaking. So this is where it gets really kind of tricky in my opinion. These are the kinds of things that we're going to be looking at towards the latter portion of the course. There is a variable here, but when you say 143 individuals, that's not a quantitative variable. That's just the sample size. N is what we usually call it. When we say 10 of the hips develop squeaking, that's not quantitative either. But when you say develop squeaking, that's really interesting because there are 2 outcomes. The outcomes are squeaks. In other words, this person had a total hip replacement and their hip developed squeaking at some point, maybe immediately, day one, they moved it, it probably hurt, and it squeaked at the same time, or doesn't squeak, or maybe it just has not yet ever, hasn't squeaked just yet, and it's coming, who knows. We'll put here, does not squeak. So there's 143 individuals, and notice we can categorize them to either squeaks or does not squeak. So this particular study has one categorical variable. Nothing about this problem says they measured the age of the people in the study or their height or anything along those lines. We are just determining if the hip squeaked or didn't. There are 10 of those outcomes that occurred, and then 133 people whose hips did not squeak. But the whole purpose of that number 10 is to categorize in one category or another. A bar chart might have been helpful to just visualize the 10 squeaking hips versus the 133 non-squeaking ordinary hips. But again, this is one of the things that makes this all tricky. We know the definition pretty well through our activities of what we mean by categorical variable, what we mean by quantitative variable, but sometimes it's not so easy to spot. There's just so much going on with this context. And so this is the major thing that we'll be practicing throughout the semester, coming up with what is the population, what is the sample, later on, describing the parameter, calculating the statistic. But an even bigger skill is we have to decide what is the variable in the very first place, because knowing what the variable is tells us what statistical procedure we run in the very first place. What are the right methods to use? How do we actually, which formulas do we actually use to calculate and get a conclusion out? So that's the major reason why we focus on categorical, quantitative, and we're going to be working on picking these out when we see a random study to determine which is it. Is it one or the other, or maybe a mixture of both? But that's my last takeaway. Chapter 1, stats starts here. It's a really major introductory chapter. We'll usually spend anywhere between 1 to 3 days finishing up an entire chapter. This one was on the longer end because we're introducing the course. And you might have noticed that the way we break things up is kind of just depends on the textbook. As we go through the textbooks, some of the chapters are really short. Chapter 1 is a short one. Some of the chapters are really long. Chapter 2 has a lot of going on, and so we break it up according to each of the individual sections. So we're looking at just section 2.1. It's about reasonably the same length as going through chapter 1 itself. So let's go up and take a look into what's going into that section 2.1. Another thing I want to mention is section 2.1 is available on week 1 because I was pretty sure we were going to start it. But when you come back to Canvas, say next week, you'll notice things kind of get shuffled around. I like to move things down in this kind of way so that my sections, or if they're a chapter, the chapters and the assignments, they're going to land and stay where we finished it on that given week. So we'll finish section 2.1, start the other sections on week 2. So that's where it's going to end up. But let's open it up. Here's our section 2.1. We immediately go back to the dichotomy that we had before of categorical versus quantitative. And chapter 2 is displaying and describing data. We're going to first focus on the displaying aspect. By displaying data, what we mean is if you have 143 individuals with hips that squeak and some with hips that don't squeak, what kind of graphic can we put down? It's going to depend on, is the data categorical or is the data quantitative? This is what our major guiding principle is to determine the appropriate way to give graphics on that data. So before we get started, this is just a fast fill out the following table kind of example. Then we'll apply it on example 2 and do a bigger project on working through example 3 when we come back next week. Well, let's get started. This one is kind of one of those sort of unfair questions until you've done it once. So here we're doing it once. As far as categorical data goes, there's a lot of different kinds of displays you could get. There's two big completing displays, pie charts or bar charts. We're going to mostly focus on bar charts in this course, in this chapter. Let's put down both for the two major ways to display categorical data. Pie charts and bar charts. And we're inundated with graphics every day. I think pretty much all of us knows when we're looking at a bar chart versus a pie chart. But let's pull one up just randomly off the internet, just for the sake of looking at one to compare to the next one for quantitative. So for just a random graphic, this is going to be interesting. I want just a random pie chart. So let's just say, or excuse me, let's do a bar chart since that's closer to what we'll be looking at. Bar chart. Let's go to images. And yeah, that looks about right. This is an interesting side-by-side bar chart. Here's our bar chart that's going horizontal for the bars. And more complicated bar chart. This would be the kind of bar chart that I'm really thinking about, one that we'll study in chapter 3, whereas some of the others we'll look into in the other chapter, chapter 4. One big feature about these bar charts is, notice there's gaps between these. Let me zoom in a bit on that. There we are. There's gaps between each one of these different columns. In every one of the columns, we have a category that belongs to a categorical variable. And the variable here was favorite color. You know, that might not be too bad to throw into the notes. Let's throw this in as our big example for a bar chart. That was bigger than probably necessary. Let's push that down. So when we say favorite color, that's the categorical variable. The colors themselves, all of this, these are the categories. So that's our dichotomy so far. Now we're going to turn over to quantitative. But any questions at the moment with our bar chart visual? Okay, now let's turn to quantitative. We're thinking of just one variable at a time. So here we had just one categorical variable. Down below, we want just one quantitative variable. There's a lot of displays for quantitative variables. Typical displays could be something along the lines of maybe a histogram. This will be a major display that we're going to be working with in this chapter. Many others could be something like a stem plot, sometimes called a stem and leaf plot. Another might be a dot plot. We'll see some examples of dot plots. You'll see some stem plots in the reading. Another one might be, say, a box plot. The major one I want to show, since we'll study that one first, is going to be the histogram. So this one was for the bar chart that we plot here. And let's give one major example of a histogram next. So for a random histogram, we're going to grab this off the internet as well. So this is always kind of interesting, slightly sketchy. Let's just say histogram. And I think that's a pretty good example right here, the very first image. The graphics are kind of fuzzy, so that's the only complaint I have. Let's go with this one. I think that's big enough to read. Okay, so here's our quantitative data. So if we're looking into a quantitative data and we're giving, say, a histogram, this is about what we're looking at. And if you're like me, you might be scratching your head on this because you might be asking, well, what's the difference between the bar chart above and the histogram below? So that's going to be one of the key things we're going to indicate here. But first, let's break it down. If you have a quantitative variable, the heights themselves is the quantitative variable. So this is our quantitative variable here. And arrow there just to say we're looking at a histogram for the specific example. Down below, these are the individual measurements that are being made. Notice what we have here then is, as far as this bar chart went, it could have been reordered in any way you wanted it. You could have put red in the middle. No one would stop you. Some people might say, I want green first. Green means go. It means I'm starting. I want green first. I want red last. Red means stop. But that's an artificial way to order those, right? There's no real great inherent ordering really for this that most people are going to think about. So if you scrambled these columns in any order you want, this display is still going to make perfect sense. But that's way different for a histogram. You cannot scramble these columns whatsoever because these measurements go in order. This is the number line, starts at a minimum measurement of 60 feet to a maximum measurement of 90 feet. You can't just take this box right here and move it over there. It would never make sense. It doesn't fit in that range. So one thing that's major as a difference so far is if we're looking at a bar chart, order does not matter for the columns. You could reorder these if you want. Some people like to have it the tallest one to the smallest one, or even vice versa. But inherently, order is superfluous. You could have any ordering. But if your data is quantitative, it's not the same any longer. And a quantitative, we have the ordering of the number line. Numbers increase in a definite, very, very orderly way. And so order is critical and cannot be changed. And we mean the ordering, I guess we could just point at the bars too. Just don't want it to get too involved with the display. So that's what's going on with the histogram. For most people, when they draw a histogram, another way you can tell them apart is there's no gaps between these categories unless there's missing data completely. That's not a hard and fast rule, but it is a rule most people obey when they produce a histogram. Well, any questions so far with our histogram versus our bar chart? Okay, maybe one question I personally would have is, if you're looking at a histogram for the very first time, it's not always completely clear what we're looking at. So if you've seen histograms before, you probably have a good feel for what's really going on. But let's think about this a little bit more. We have a frequency column that goes from 0 to 10. We have the actual measurements, the heights of those individual cherry trees that goes from 60 to 90 feet. And what this display is really trying to say is, if you focus on, let's just say, one of these rectangles, any one of them, there's 6 altogether. Let me focus on this one. It ranges between height of 65 feet to 70 feet, because that's the horizontal distance on that axis. But its total height goes up to a height of 3. So this is what the histogram is telling us. It's telling us where all of our data actually falls, how it spreads out, where it accumulates. Lots of trees in this range from 75 to 80, but it starts to fall off towards the left, fall off towards the right in a fairly symmetric way, not perfect. So what this column is saying is there are 3 black cherry trees. The 3 came from that 3 right there, the height of the rectangle. So 3 black cherry trees between heights 65 and 70 feet. Let's say of heights. I think this is a better way to say it, of heights between 65 and 70 feet. So that's what's going on with our display for quantitative. I feel like it seems like a much more complicated display in a certain sense, but the categorical data above wasn't trying to do anything too different. That's really hard to see. I should have taken a better screenshot, but that number right here is 8. And this is just saying 8 people have red as their favorite color. 7 people have blue as their favorite color in this data set, and so on. Only real difference here is the ordering is what's causing this to look like a slightly different display. But any last thoughts or questions at all, folks? Looking at either one for categorical, the bar chart, or quantitative, the histogram? Okay, well, this is the theme about chapter 2. We're going to describe data by first displaying them. And when we say describing data, we want to go even a little bit further. When you look at this display, you might make guesses of what's the maximum, minimum, what is the average number for the height of these cherry trees and so on. So we're going to calculate to produce our own statistics. We'll be using the calculator to make some of those computations happen. And that's where this chapter is going. First, we're going to focus on categorical, and then the rest of the chapter is going to focus on quantitative. Well, we've got about a couple minutes. I don't think that's enough time to make a huge amount of headway on example 2. So instead of breaking that problem in half, what we'll do is we'll review what we described here for typical displays, and that'll be the example that starts us off on our next week on Monday. Well, we'll stop a little bit early today, just about a minute and a half. Any last questions or thoughts before we call it a day? Okay, well, have a great weekend, folks. Again, if any kind of questions come up whatsoever, don't hesitate to email me. Send me a question at any time, even on the weekend. I check my email very regularly, even on the weekends, usually in the morning, not so much throughout the day into the evening. But if you send me, say, an email at 3 a.m. on Friday, maybe 9 p.m. on Saturday, I'll be getting to your emails either, say, Friday morning around 8:30, Sunday morning around 8:30. I'll always just start off my day by responding to whatever questions come up. But have a great week, folks. We'll be back to it on week 2. Thanks. See you later.